Hello students, in today's session of work power energy very basics on conservative force and potential energy, we will discuss through illustrations. In earlier session we have gone through these which you can review on statistic law. I would also like to say these two papers detailed solution available on statisticlaw.com. You can have the solutions by visiting the site. इसी के साथ साथ मैं आप लोगों से रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल सेटिस्फिकेशन सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the concepts and questions. Concept regarding conservative force and potential energy. Conservative forces. Conservative forces are those in which work done depends only on initial and final positions. That is path independent. Conservative forces are those in which work done depends only on initial and final position, that is path independent. For closed loop, for conservative forces, work done equal to 0. Examples: gravitational force, Coulomb force, spring force, all are examples of conservative forces. Potential energy is mgh, अगर height वाले due to its position is defined for conservative forces. What is the energy associated with position or configuration is known as potential energy. mgh भी हो सकता है, something else भी हो सकता है, ठीक है. Potential energy defined is, and mechanical energy under conservative force remains constant. WAB, A2 work done, equal to minus du, that is minus UF minus U initial. This is regarding the conservative forces, work done, potential energy, right? Let's start with the question. Question is, a chain of mass m length L is kept in three positions: position 1, position 2, position 3. As shown below, assuming h equal to 0 on the ground, find the potential energy of the chain in all the three cases. Concept applicable and solution. Potential energy is given by mgh. This is for point mass. If object is extended, then height of the object is to be considered from center of mass. Center of mass, where whole of the mass is supposed to be concentrated, right? Then potential energy mg hc, center of mass, is the height of center of mass from reference point. In this case, it is ground, right? Now, position 1. Position 1, Hc equal to 0. Therefore, potential energy will be equal to 0. Position 2. Position 1, Hc equal to H. Therefore, potential energy will be equal to mg Hc, that is equal to mg H. Position 3. Hc equal to H by 2. Potential will be equal to mg Hc, that is mg H by 2. These are the all cases. In all cases, potential energy is calculated, right? Next question. Question is, potential energy of a body in position A, minus 40 joule. Worked by the conservative force of this potential energy is moving from point A to B is minus 20 joule. Find the potential energy of the body in position B. What is conservative force? What is conservative force? Conservative force is that which depends on initial and final position and not on the path followed. That is independent of path followed. Independent of the path followed. Now, work done from W A to B equal to, that is matter delta U, that is minus U final minus U initial equal to this. That is minus UB minus U minus U. Answer the minus UB plus U minus W A to B take सकते हैं, ठीक है? Therefore, we have to find UB. UB will be equal to UA minus W A to B. Substituting values. UA is given to minus 40 minus 20. On simplification, this comes out to minus 40 plus 20, that is minus 20 joule. This is the potential energy at point B equal to minus 20 joule, right? What is the conclusion in this case? Potential energy is increasing from A to potential is increasing from A to B. Therefore, work done by conservative force is negative. Work done by the conservative force is negative. From A to B, that is from -40 to -20 joules. Right? Next question. Question is, a particle which is constrained to move along x-axis is subjected to a force in the same direction which varies with the distance x of the particle from origin as fx equal to minus kx plus ax cube. Here k and a are constants, positive constants. For x greater than 0 means we have to consider value of x 0 or greater than 0. The functional form of potential energy ux of the particle is, we have to pick up one of the correct graph. Concept applicable. Potential energy is defined for conservative forces. Conservative forces are those in which work done is path independent. That is, depends on initial and final condition, not on path followed. Right? And f is given by minus du by dx. Slope m equal to dv by dx. So this is the in terms of slope also. Now, du will be equal to minus f dx, substituting the value of minus kx plus ax cube dx. On simplification, this comes out to kx minus ax cube dx du. Integrating, we get ux equal to 0 to x kx minus ax cube dx. For the formula applicable, x to the power n dx equal to x to the power n plus 1 divided by n plus 1. Therefore, ux comes out to be minus kx square by 2 plus kx square by 2 minus ax 4 by 4. ax 4 by 4. Now to find values of x for which x equal to 0. Therefore, kx square by 2 minus a x 4 by 4 equal to 0. So x square by 4 taken common, so this comes out twice k minus ax square equal to 0. So either x equal to 0 or x equal to plus minus 2k upon a under root. Considering positive sign only as x greater than equal to 0. Therefore, x equal to 2k by k. Now, as f equal to minus kx plus ax cube, f equal to 0 at x equal to 0. Therefore, slope, that is f equal to minus du by dx equal to 0 at x equal to 0. One is this discussion, and another, find value of x for which ux become negative. On substituting x greater than under root 2k by a, u will be negative. U will be negative, right? Means now in this case this is always positive. In this case, at this point this becomes negative. In this case it is always negative. In this case slope is not zero. So this is the correct answer. Option D is correct answer. Right? Now, I would like to request, if you are new to my YouTube channel, Set His Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.